Alright, what's up guys? My name is Feridan and welcome back to, no wait, welcome to my very first guide, tutorial thingy, I don't know how you call it. Yeah, as you can see I'm not that professional with it. Also I hope you don't see this mouse flickering thing, I hope the mouse looks fine for you, for me it's flickering all of the time. Pretty annoying. Now, yeah, what's this guide about? Well, it's basically about how you can make a C# script to access the camera module of the Raspberry Pi. It's a pretty long title. I don't know how we're gonna put it in the title of the video. Yeah, as you can see, I'm not that prepared. Also, just one thing. Um, if you don't have a Raspberry Pi yet, or you have bought the parts but you haven't set it up yet, I have a link in the description, so I'm gonna put one when I put this video up, which will get you to a video which will show you how to, well, how to set up your Raspberry Pi. And also, I'm probably gonna put another link in the description on how to connect the camera module to the Raspberry Pi, because that other video doesn't include it. And yeah, other than that, you might also want to know the parts of the Raspberry Pi. So basically, what you need, what's essential is the Raspberry Pi mainboard, which is the Raspberry Pi itself. There's the CPU and all that stuff, everything included, because it's well, it's pretty small. Secondly, you need a power adapter of a Raspberry Pi. That's because, well, without energy, without any power, it's like you'll have it, but it won't be working, right? And other than that, you'll also need a micro SD card because, well, you know, to store all the data. And yeah, that's basically to the essential. Yeah, also you need a camera module, of course. It's not essential for Raspberry Pi itself, but you know, for our case it is, because you know it's basically the project. And other than that, you also need the like keyboard, mouse, monitor, obviously, like just the basic input output devices. And if you want to listen to some music during you're doing all of that stuff, you can actually, because there's an audio plug as well. So yeah. All right. Also, yeah, basically, when you start the Raspberry Pi the very first time, the computer, then you will be greeted with which OS you want to install. Just choose Raspbian, and yeah, also make sure that the micro SD card, good that I didn't forget it, is of noobs. And the reason for this is it's not necessary for it to be noobs, but it's gonna make the installation process a whole lot easier. It's literally 2 clicks. I don't know how hard it is without it, but I heard it's quite a lot harder. So yeah, make sure it's with noobs. Also, you can buy a Raspberry Pi case. It's probably recommended because, you know, first of all, it's secure, and second of all, the much more important reason, of course, is because it looks pretty fancy. Um, but yeah, also just remind yourself that you need to take the top off so the camera module actually has space. Other than that, it would just be inside the computer. When you put the top off of the case, then you actually like have room for the Raspberry Pi camera, right? Um, if I forgot anything, I'm probably gonna edit it afterwards, and you'll see it somewhere beneath now. But yeah, so let's get started. So the very first thing, also, I know I forget some stuff that I want to say, but I have done nothing other than you know, the basic installation process of the OS. And when you start the very first time, it also greets you with welcome to the Raspberry Pi. And then it will ask you for the country region, for password, if you want to connect yourself to the Wi-Fi, all that kind of stuff. Then when you, it also asks you if you want to install some packages, and that might require quite some time, but I'd recommend you to do it. And then it will reboot itself, and basically this is the standpoint I am right now. I've done nothing before recording this video. You might ask yourself, well, what's this thingy right here? Well, it's basically, you know, let me show you. It's the recorder in order to record the screen. But yeah, other than that, it's pretty much it. Wait, is it recording? Yeah, it is, good. Um, so yeah, what's the first thing we want to do? We want to open the terminal. Now, the terminal is actually here, but the shortcut to open it would be Ctrl Alt T. And yeah, now we have it open, and first thing we want to do is we want to look if the camera is actually working. Now the way we can do this is when you install Raspbian, which is by the way based on the Debian distribution of Linux, then you will have some additional tools. For example, Raspistill and Raspicam. Raspistill is based around making images and all that kind of stuff, and Raspiwid, sorry. Raspistill is based around making images, and Raspiwid is based around making videos. You know, it's kind of obvious by the name. And yeah, so now we can have a full screen preview by making, for example, Raspistill or Raspiwid, doesn't matter because it's only a preview, with making Raspistill space -f as the argument. And you should be seeing that it shouldn't work now very well. Don't worry about this because on default, the camera is actually not enabled. So you first need to enable it, because you know not everyone gets a camera with the Raspberry Pi, and the way to do this would be you make sudo, which gives you super user rights, then raspi -config, and press enter, and now you will see it kind of looks like the BIOS if you're familiar with Windows. So what you want to do is you want to go to interfacing options, and want to select the very first option, camera. Would you like the camera interface to be enabled? Yes, also I have some of the stuff in German, because, you know, I selected the region, Switzerland. Yeah, just, yes, yeah means yes, alright? Yeah, just click on yes. The camera interface is enabled, perfect. Now you can, with the right arrow keys, go to finish. Now it's gonna ask me you to reboot. I'd recommend you to do it, so I'll see you afterwards. Alright, I'm back again. I've just restarted rebooted the Raspberry Pi, right? So open up the terminal again, and now we can actually test Raspistill. And you should be seeing the video of yourself if you have the Raspberry Pi correctly connected. It should be a timeout of 5 seconds on default. Now you might have, no, you probably didn't see it, the video itself. But I saw it now, and the reason for this is because the recording device doesn't actually capture it, because it's like basically on top of it, so it doesn't capture it. But I just saw a 5-second preview of my camera, meaning it is working. You should be having the same thing. If not, you probably connected the camera wrong, or just type in the error, whatever you see in Google, and it should help you out. Or DuckDuckGo, because Raspberry Pi uses DuckDuckGo as the first internet search engine, right? So now we actually have our camera set up. So the next thing we can do is we want to set up our environment for coding on C#, which yeah, so that's basically .NET. And now there's one important thing to know, because actually, like, C# wasn't made really for supporting other OSs than Windows. That's because that's the reason why there's not a lot of support for C# on Linux and Mac, anything outside of Windows, you know. And because, like, basically the way it worked was there was .NET Framework, and this was the platform which C# was running upon, and it only supported Windows itself. And, you know, some like Mac developers and Linux developers weren't all that happy about it, at least the ones which wanted to code on C#. So what they need to do at the time was they need to install a virtual machine, and basically have Windows on there, and, you know, that's kind of complicated. It could be a lot easier. So a small group of people agreed with me, and they were like, hey, let's actually, like, you know, do something so it would work. And these people were called Xamarin, it was basically the company name, and they made a project called Mono, alright? And Mono, its main goal was basically to provide C# or the entire .NET platform for OSs outside of Windows. And they made it so now you could actually be using, when you install Mono, you could be using C# on Mac and Linux. And the way it would basically work is it would translate the C# code you have For what it would actually do on Windows, it was basically translated for your operating machine. So it was now platform independent, right? Now Windows was like, hey, it would actually be a pretty good thing if we would have done it ourselves. So what they decided to do was they basically well, they first of all bought Xamarin, and that's a nice thing to do. And then they made .NET Core. Now .NET Core isn't out all that long, but basically it has a lot of improvements above .NET Framework. And but one of the main things that has happened is that .NET is now platform independent, so you can code on C# and anything without Mono. Now you might have asked yourself, well, why did they actually make .NET Core? Because they Mono already existed, and they even bought Xamarin. Like, what was the point of that? Now I honestly don't know why they bought Xamarin. Probably they were just good coders and all that stuff. But the reason they made .NET Core was because um, at that time when Mono was made, I'm not sure if it still is, but .NET Framework wasn't open source. Now Windows actually recently starts to making projects more open source. I think .NET Core is now open source, but .NET Framework wasn't at the time. So what they basically needed to do was they needed to build an implementation on top of the already existing .NET Framework. But since Microsoft has access to their own code, obviously, what they can do is they can just modify the code itself instead of building on top of it, which is better for performance-wise. So yeah, they made .NET Core, and now we basically have these two options. We can use either .NET Core or Mono. Now you might be thinking we would be using .NET Core because I was just praising it a few seconds ago, but we're gonna use Mono, and there's quite a simple reason for that. Um, to be brutally honest, this is a school project, right? And I already made a documentation and coaching with showing of Mono, and yeah, I'm now too lazy to actually look how it would work with the .NET Core. Now, let's take on a second reason. And the second reason is that .NET Core is quite buggy, and it's quite a big process to actually get it working on Linux. Let's just assume that this was the reason why I'm doing it with Mono and not .NET Core, alright? Now, but yeah, let's just use Mono now. And also, just a little thing to notice is we could be using we could be using .NET Core, and if you wanted to, you could also use an IDE, which is an integrated development environment. And while Visual Studio, which is the main IDE you want to go to with C#, it only supports Windows and Mac, but not Linux. But Visual Studio Code, which is not the same thing, it's another IDE, but also from Microsoft. This supports Windows, Mac, and Linux. So you could be using Visual Studio Code for as the IDE. But the thing is, I want to keep everything simple. We're just gonna use the basic IDE, which is wait, let me check out. Where is it? No, wait. Okay, I'm pretty bad with this. Bureau, probably no. Entwicklung. There we go. Genie. Yeah, it should be on top of you, something like the development. And this is the basic. It has basically, it's almost a text editor, has almost nothing that you can really help with. But it's also good because the Raspberry Pi isn't really that good for performance. It's a pretty small computer, it's obvious to expect. But you could be using Visual Studio Code. Alright, now, yeah, let's install Mono. Now to do this, we want to do, first of all, we want to do this. What I'm doing right now is we're gonna install many tools from the apt-get tool. Now the apt-get tool has access to a big database with many packages of different tools that you can download, right? And after fresh install, it's always recommended to do sudo apt-get update so that you update the tools, right, that are available on the database, and then you actually want to get them with sudo apt-get upgrade, and now you basically get that new information that you've gotten from the update And yeah, you want to press yes. And yeah, as you can see, a lot of new stuff has occurred, I think. Yeah, I really don't know. So this might take quite a long time. If it's gonna take too long, I'm gonna cut it, and we'll see ourselves after sudo apt-get upgrade is done. Alright, so I'm back. It should be done now. Let's just press Q to quit. And oh, yeah, probably not quite. Alright, so I'm back again. That process right here took longer than expected. You might get an information like this. It tells you to reboot your Pi. If it does, then yeah, just basically do it. And yeah, now we should be done. Right, so I'm gonna reboot my Pi. I recommend you to do the same thing, and we'll see ourselves later again. Alright, so after rebooting the Pi, let's go back to the terminal. Let's do what we actually wanted to do from the beginning, and this is we wanted to install mono. So how to do this is sudo apt-get install, and now the package name would be mono complete. And yeah, therefore you will get the entire mono package. Just press enter. I'm not sure how long this is gonna take. Just press. Yeah, by the way, if you press enter when it asks you if you want to continue, it's always gonna do the option of the capital letter, the uppercase letter, however you want to call it. Just the big one, right? The yes it would be in our case. So let's just press enter because we want to continue, and yeah. This seems like it's gonna take quite a while as well, so I'm just gonna skip it. Alright, so after this installation is done as well, we should actually be ready and set to code in C# already. Yeah, that was that easy. Took some time, but basically it. So all you want to do is you want to, oh, oops, see, I'm used to being on Windows. You want to open this file manager. By the way, you could also be navigating through the CLI, which means through the terminal, because basically, like, you can see the path we're in right now. This kind of thing called what's I think tilde or something like this. On German it's tilde, I think on English same, but I don't know how to pronounce it. And now you will see which path you are now. Default wise you set on your user directory, which is basically the Pi in our case. And yeah, so you could be, for example, going into specific directories by making cd and then videos, and now you're basically tilde videos, means you're in there with cd, which is change directory, // you can go one back, and if you do this again, you will see that now the slash is the very root, that's the very beginning of our entire root system, you know. And with home, we're in our home, and now yeah, basically we can go back. And by the way, if you don't make a slash in front, if you make a slash in front, you're starting from the very root. If you don't, you're starting from the position of the current directory you're at. So I could either go like cd /home/pi/ yeah, videos, and I'll be in there, or I could simply say cd videos because I'm already in home Pi, you know. Basically that's like that. Just some quick little info for the Linux beginners here. I'm not actually that advanced with Linux either, but yeah, just you know, some information. Now we're gonna make a new folder first of all. Again, we could actually do this through the CLI as well, but just not to confuse you, let's make a folder and let's call it something like program. I want to call it projects, but I'm probably gonna do a projects folder afterwards. And now let's call it our hello Raspberry Pi. Very good name. And hello rasp.cs. Make it a .cs file, it doesn't matter what you call it, but with CS you're basically indicating that it's a C# code which you can later on compile. So now if we double click this, we should, yeah, it should be opening default-wise on Genie. And yeah, now we can actually start writing our code. Now I'm gonna first of all make using system. This using is basically import in other languages. And now we can say it's an object-oriented programming language, right? So you can say class program. It's really nice to do it with this, like without a proper ID, but whatever. And now we can just make our main function. I assume you have some C# knowledge. If not, then well, you're kind of fucked. I hope I'm not getting demonetized now. Whatever. So now we want to do console.writeLine, which is basically to write in the console. That's the command. And as the parameter for string, oops, you give whatever you want to write. So we're gonna say hello Raspberry Pi, just like that. And now, as you can see, it's red, means it's not saved. Control S is gonna save it, or you click on File and then Save. Also, I'm sorry that it's on German, but you can just kind of figure it out, I guess, with the position of all that stuff. And yeah, that's basically it. And now, how can we actually run this code? Well, we're first gonna need to compile it and watch closely what happens here. I'm gonna compile it, right? Here's the button. Boom, you see it's a .exe file. Now actually, an exe file is made for Windows. It's an executable file for Windows itself. Now, that's kind of the reason why also C# doesn't really support Linux, you know, and other like Mac and Linux, all these OSs. But here's the thing with Mono, like Mono is the whole purpose to actually like make it work for the individual OSs, not just for Windows itself, and therefore it can actually use the .exe file and make a proper like program out of it. And there we go. It says hello Raspberry Pi. Now, just to let you know what happens in the background, I'm gonna do the same thing with the CLI, just so you can see. So let me open the terminal again, and let us go into exactly the programs. Also, if you tap click on tab, then it's automatically gonna open the folders. Now, if there's multiple folders, let me just show you. For example, I make yeah, there's multiple ones of this. If you tap, it's not gonna select anything. If you double tap, you're gonna see all of the folders with the specific name. It also works for files, by the way. Now, if you make I, then you can see this is the only actual folder which exists with this prefix. So Pi is only pictures in there. Programs public doesn't apply. If you tab, it's gonna open pictures. Now we actually don't want to open pictures, but programs. That was a brain fart right there. Now what we're gonna do is, yeah, we're basically gonna go in here. That's the only folder, so it's gonna open it. And let's go in here, right? And now what you can do is first we're gonna compile it, right? Now MCS stands for Mono C# compiler. I don't know why they call it MCS. It should be either MCSC or MCC, you know, Mono C# compiler. But whatever, they just forgot the compiler part. I don't really mind. Mainly it works. That's the good thing. So now what we're gonna say is we want to put in. Let me just delete this exe file so you actually see that it's working. It would otherwise overwrite it. Now MCS hello rasp.cs. It's just our file, right? .cs. Now it's gonna, if you press enter, you will see it does the exact same thing as we clicked here on compile. And now if we type, in order to execute the file, we're gonna use mono, right? Now, I'm not actually sure if I told it, but just quickly, the MCS, it's also a tool which is being installed when you get mono complete. So it's part of the mono complete thing, mono and MCS also. Without installing mono complete, you wouldn't have either MCS or mono. Now, yeah, MCS is for compiling the C# 2.exe, so it's an actual usable exe file, right? And to execute this file, we're gonna use mono. So hello rasp.exe. Now the way it actually, you can see it works, the way it actually does it here is it first compiles the file into the same name, hello rasp, and then just as the extension .exe, and if you execute it, then we are not actually in the exe file right now. This is the .cs file, right? But it searches for the same name, just with, instead of the cs extension, it has the exe extension. Execute. I don't know how to pronounce it. I'm bad at English. I'm sorry, alright? So, yeah, now basically this would be it. As you can see, it's working. Now, that's pretty good, but we're not here for a hello world kind of program, you know. We're here for the camera module program. So what we're gonna do is, it's a little harder for this one. We're not gonna code everything ourselves. We're gonna yeah. Let me just quickly show you. First of all, we need a NuGet package manager. We need a package manager, and this one is gonna be NuGet. Now, if you've worked with C# before, or mainly Visual Studio, then you probably know that you probably are familiar with NuGet, because this is just a package manager which allows you to have dependencies on other projects or programs that you don't need to code everything yourself, right? Now, for Visual Studio itself, it's actually pretty easy to use because this IDE does everything for you. But here it's a little more simple, so we need to do more of the stuff ourselves. So first of all, we want to install NuGet, because we're going to use packages afterwards, because it's going to be a more complex program than just a hello world, right? So we want to again make the process which we already know, sudo apt -get, and then we want to say NuGet, because, well, it's NuGet, right? Oh, sorry, install, I forgot this one. Alright, yes. If I remember correctly, it didn't take that long. But either way, if it takes too long, I guess I'm gonna skip it. Oh no, yeah, I was right. It didn't take that long. Now we should be having NuGet. If you type in NuGet, you should be seeing, there we go. Basically, whatever it can do, it shows you the whichever command, so the single arguments actually. No, sorry, those are the commands. It shows you what they actually do, right? And now, first of all, if we scroll up, we can see it's version 2.8.7.0. Now, I don't know why, but it installs by default this version. It's quite an old version. In order to update NuGet, you're gonna write NuGet update minus self, and after it updates, we should be on the newest version. We by the way need to update it, because there's some packages I realized that well, they require a higher version than version 2.8.7, something like 3 point something or 4, I'm not sure. Oh, sorry, it also requires a sudo. Sudo is super user privilege, you can do everything with it, right? Alright, so once it's done installing or updating, let's type in NuGet again. And scroll up, and we will see it's on version 5.0.2.59888, no, 88, whatever, just the most recent version, right? So that's good. Now we can actually continue. So which are the actual packages we want to install? Well, wait, let me close this so it doesn't distract us. Also, let me close this as well, and we don't need this either. Alright, way more practical and cleaner. So what we're gonna do, we want to install some projects. Now, we want one which gives us access to the Raspberry Pi GPIOs, and in general the hardware, like all of the kind of pins, through our code. And for this I found actually multiple projects, but in my opinion the best one, or at least the most well maintained one, is by Uno Square. Hang on, I'm not sure if it... Alright, so quick disclaimer, if, like, I think I forgot to tell on how to connect with the Wi-Fi, but it's actually really simple. Like, you might either take a Ethernet cable, or you can actually just connect with the Wi-Fi. There's nothing to do. You can just yeah, I should have probably told it before, because in order to install the packages you need internet, whatever. You can just select one of them, and then it's gonna ask you for a password. If it has one, just type it in, connect, and it should be working, or just use an Ethernet cable, whatever you want. Alright, so now what we want to do, yeah, Uno Square. Actually, let's Uno Square is actually a company which like makes projects. Wait, no, I shouldn't be opening this one. I want to open their GitHub. Yeah, let's go on Uno Square Raspberry IO, because this is everything about the Raspberry IO, right? There we go. I just made a typo, whatever. DuckDuckGo is smart enough to catch that. Alright, so now, yeah, I already said Uno Square, the Raspberry IO package is, it actually says here, a hardware access for the .NET, so you can actually access from the .NET the hardware of the Raspberry Pi. And this includes like some of the GPIO pins, which we're not gonna look at, but most importantly in our case, it's gonna be where is it? There we go, camera module. But before you can do this, it actually has already an example which works perfectly fine. Very proud of that. Thank you very much, Uno Square. Big shout out to you. Now what we actually want to do is we want to first install it, right? So let's go on installation here. And now we only want to copy this part, because this is the actual like package we want to install through NuGet. So what we want to do is we want to open our terminal again, and now we just want to install the Raspberry IO package. And yeah, let's just do this. Oh wait, before I forget it, let's first actually make a projects folder in which we're gonna install it, just so everything is a little bit more sorted. This is where it comes into place, right? Projects, perfect. Now we can just go in there as I showed you before, cd projects, but without a slash. What it's gonna do is, if we're gonna install any packages or anything, it's gonna do it inside this folder, which is really good, because I don't want to figure out whatever was here before and what were the packages installed, right? So what we want to do is we want to install through NuGet, which we just got, and the way we want to do this is sudo NuGet install, and then our package name, right? The which we want to install, which we would paste into here with not Control V as you might be used to, but Control Shift V, right? Alright, now that this is done, let's just press enter. And now this might take a while, so I think it's not too long. Alright, so it's already done. I was correct about this. Now let's just open up our folders, and let's go into projects. And you should see here that we have 4 files. Now those are all of the ones which we need for Raspberry IO. So thank you for making it this easy, Uno Square, again. And now we don't need wiring pi or any of this stuff. Peripherals is, I think, no, we just need it, right? Alright, so now the next thing we want to install, there's still other stuff we want to install, but not from Uno Square. That would be the .NET framework thing. Now, because there's quite some commands or classes, I mean, like for example action and other stuff which we're gonna use. I'm gonna get to that later, and for this we need the .NET framework NuGet package itself. So for this, just search for net standard library NuGet. I hope it's gonna find it like this. Oh, I think it's this one. Net standard library. No, wait, it's net standard library dot net framework. I thought it's gonna find like this, but whatever. Alright, there we go. I think this one is it. Yeah, perfect. Now what you want to do is, it has some weird version names. Don't ask me why they decided to do this, but you basically, again, just gonna, okay, apparently you need to copy the entire part. Let's also make sudo NuGet Ctrl-Shift-V, right? And let's just remove this install package part. This is a different way to actually install it. And now we actually, yeah, this should be it, the newest version. And you should be seeing afterwards. Let me actually already open it up. Oh wait, was there an error? It's an unknown. Oh, of course, I also get this. Sudo NuGet install, everyone. Alright, now that it is done, let's go into projects, and we should see some more projects. Isn't this cool? It actually might have been a good idea to make different folders for those as well, but nah, it's actually fine. And now I think that we might need to install also system.runtime. This happens sometimes, like sometimes it says it's required and sometimes not. I've already done this entire process for the guide and for the documentation. If it tells you that you need to install system.runtime, I'm just going to quickly show you. You're just going to search for NuGet system.runtime. Or actually, you can just make NuGet sudo NuGet install, and exactly you would just have this exact package right here, right? And it shows you, yeah, you could just paste it in here and remove the starting part, right? Install package here, and you could get it, but I'm not sure if we need it. Just in case we don't, I'm not going to install it right now, but if we should, then we will see an exception. All right, so now that this is done, let's actually go back to our programs folder, because we want to write now our code for on how to doing this, right? So our camera module. So the way we want to do this is let's first of all make a new programs folder, which we're gonna call Raspberry IO, just like that. And let's make a file and call it Raspberry IO.cs, something like this. And now what we can do is, let me just quickly close this and this as well. Now we're back in the GitHub page. Let's go back here into the camera module, right? So first of all, let's again make this using system, because we need this always, and also say class program, where we go give just like that, static void main. And now we should be having access to yeah, a program. Now let's actually copy this test capture image. It's for capturing images, as the file might actually say, right? God damn it doesn't have a formatting option. Well, let's just quickly I should be a little more prepared for this, but whatever. So now that we were done with this, let me just quickly explain. Like, the test capture image is actually pretty easy. Because what we can do here is, what it does is it uses the, hang on, I need to first of all import some other stuff in here. Because we're not just using system, but we're also using what we've just installed. This would be uno square dot raspberry IO. I almost make a triple R, I don't know why. And we also want to use raspberry IO.camera. Alright, now that we're done with this, what it actually does is it accesses the raspberry IO, right? Pi.camera, and now it says that the method capture image. You're specifying the resolution you want here, the image, and then it's going to return this as bytes, right? So the Raspberry Pi itself. And now you can just specify a target path. If the file exists, it's going to delete it, so because it doesn't override it, I think. So it's going to delete the specific target path, so it actually has space on saving it here. And now you would just use the normal file.writeable to well, write it in here. In fact, I think I also need to, yeah, using system.io. System.io is also the namespace you would use for file. So with file.writeAllBytes, you specify first the target path and then the byte array. And then the byte array is going to be saved at the target path and it should take the image, right? Now the next thing is a little more complicated, and this would be the test capture video, alright? So what I'm going to do is we're going to copy this, paste it in here just as we did, and let me tell you what it actually does. Let's make full screen, and now, yeah, actually it has some comments, so that's pretty good. And we actually don't need this, it's just, you know, here for some information. And now this the part where it gets interesting. The camera video settings is, it's a class where you can specify all of the settings which you want. It's, by the way, the same ones as in the Raspberry one, you know, we were using. Hello there? Can you please load this? Oh, there we go. Yeah. We were using Raspberry still, right? We had like options like -f. We have all of these here now. It's just written out loud. Alright, so yeah, we, for example, timeout on how long it makes the preview is 0. Now the capture display preview is set to false. We want here preview. It's gonna flip the image vertically, which we could, for example, also do here with Raspberry still. Capture exposure. You can even set the camera exposure on like when you're recording for night. It's going to adjust it and stuff like this, and then the resolution itself, capture width, capture height. Now what it's gonna do afterwards, it's gonna try to open this video stream, and in case nothing goes wrong, like it opens it, right? Now you're gonna first, as the first argument here, as the parameter, you're gonna pass in a object of type camera video settings, and it has all of the settings. The next thing is gonna be a action byte array type, and basically you're specifying here with a lambda expression. You could also just be using an you could make a method and then just return it in here and write the name of the method in here, but you can also just make an anonymous method like this, and I'll get to this later on. The onExec callback, we can just leave it as it is. Now you might ask yourself, well, why do we actually use like initialize start time here again, like give it a value, when we already did the exact same thing up here? And I was actually questioning myself this as well, but then I realized that like the idea behind it is that you want to initialize time here, right? After the user interaction, after the camera starts recording. And if you were just to make it like here, var start time, then you wouldn't have access to it where we actually reference it, because start time is being, wait, where is it being used? Here, right? There we go. Here's start time, and then this is why we need to initialize it here. And now you might be like, well, why don't we just declare it here but initialize it here? The reason for this is because if we were to get here an exception, then we would go into the catch block, and in the catch we wouldn't be assigning a value, so the finally is always being executed, and therefore an exception would occur because start time wouldn't have a value, right? And yeah, that's about that. Now we could also just give it a value in the catch, but why do so when we can just reference it here directly, right? I mean, initialize it here. And yeah, all right. So now after the start time, what we're here doing, we're just telling the user that he can like press any key, and then we're waiting for something to be pressed. So once it's pressed, what's going to happen is we're basically going to continue. It's kind of like a breakpoint on runtime where it doesn't continue the code until the user types in a key, right? Now, if we were to fail, then we would get the exception and the type and the message, and either way, like try and catch both results into the finally, right? And what happens in the finally is you always want to close the video stream, so no like data leaks are happening, so that the stream won't just always be open. And other than that, we're just opening the stats, right? So for example, megabytes received, yeah, we're dividing the video byte count by, well, I mean, we're technically getting the bytes itself, right? So times 1024 would be the kilobytes, and times 1024 again would be the megabytes. And this would be the format type, the toString. then we're getting the time of now, subtracting it from the start time, so we get the in total seconds we get the amount of how long we were recording, also with this format. And at the end we're just outputting all of these stats. By the way, this the way you can do this in C# is like with, if you put the dollar in front, then you can do formatting strings. So if you have these curly braces here, then we're gonna actually, like, the value of this exact object will be reference or variable, right? And yeah, that's about it. Now also, before I forget it, I needed to, like, I was doing this, I sometimes make edits, like I sometimes cut the video when I edit, and I forgot to point out that I also need to use system.io for file, which we are using in the test capture image. This file class is inside its namespace, right? All right. Now, you will realize if we try to compile this, then we should, yeah, be getting an exception. And you can already see it, the typo name, space name, unisquare could not be found. Are you missing an assembly reference? By the way, yes we are. Quick spoiler alert. I should be doing the spoiler alert before I'm telling it, but whatever. And yeah, you can also see it's actually like formatted, right? And the reason why this is happening is because, like, we're telling we want to use this namespace. And by the way, Visual Studio does this for yourself, but like here we need to do most of the stuff. And we're telling we want to use this, but like, how the hell should the program know where this exact assembly is, right? We kind of need to reference it. So the way we'll be doing this is also, it happens the exact same thing with like when using the CLI. So if you type in, for example, MCS, and then you go into programs, and then we would have what do we, yeah, right, Raspberry.io and Raspberry.io.cs, then you will see we'll also get it. So the way we can fix it is, well, as I pointed out before, we can just say the program where the assemblies are. And the way we want to do this is we want to first type MCS and now /r:. And what we're going to do is we're going to specify the path of the single assemblies we need. And let me just open the file manager real quick. Also, let me make this smaller so it's a little bit better organized. Perfect. And now we have our projects folder, right? And we need, for the compilation, like for the compiling part, we need to reference first of all Raspberry.io, lib, that's standard 2.0, and here. Now we need to reference the path to it, but there's a quick little tip on how to do it pretty quickly, and this would be with right-clicking and then copy file path. I think it is what it's on English. And now just Control-Shift-V again. Now, if you want to reference multiple ones, you're just gonna redo the process, right? And the next one on the reference is Net Framework, which would be, I think, yeah, perfect. The net standard, the library.net framework, the 2.0.0 preview, whatever the version number was, build, then I think 461 lib, and yeah, perfect. Net standard.dll, again, copy file path and paste it in here. Now, if you're wondering yourself how they actually know like which one are being used, well, if something's missing, then it's like it's telling you here, right? It's missing unisquare. And when I wasn't using net standard, then it told me, well, you're missing net standard. So I just kind of Googled and found out where to find these assemblies, right? Now, the last one we need to reference for the compiling part would be the swan.light. I think, yeah, perfect. Copy file path. Just like, oops, just like this. And now, oh yeah, of course, we also need at the end to always give the project which you actually want to compile, obviously. So this would be again the project programs, sorry, / Raspberry.io, Raspberry.io.cs, and perfect. So if it doesn't say anything like this, then it worked, right? And now yeah, something important actually to notice. I think I almost forgot to tell it, but sometimes, like I was doing this process before, right? I already told you I made a guide and the coaching, and I did this multiple times. But sometimes it actually required me to install system.runtime. So if it does for you, if it tells you still an exception, you need system.runtime. All you want to do is sudo NuGet install NuGet. I used to call it always NuGet, but that's wrong. So then you get install system dot runtime. Now you can also like I think the most recent version of time of recording this is 4.3.1, but you can like it might be probably a newer one if you see this video. So just you can specify the version or not. I think then it's just gonna install the most recent one. And yeah, but I don't need it as I could see right now, so I'm not gonna install it. All right, now for the executing part, because now you should see if we go to our programs, Raspberry.io, you can see raspberry.exe, right? It compiles, so that worked. Now to execute it, it's also not as simple as it used to be, because we can just go into programs /SBO, then .exe. You will see. Oh, right. I just noticed this. In our main function, we always need to call one of these two. Test capture image. Let's do this one first. Save it. Now, okay, I need to recompile it. Now, the way you can actually like use the command which you used before, instead of needing to type it all over again or just like copy it, which would probably be the easier thing. But the easiest would be to just use your arrow keys going up, gives you the most recent one, another one up gives you the second most recent one, and so on, you know. And going down reverses this process back to nothing. So click 2 times up. And now you will have the MCS again, because we always need to recompile it if we do changes. So press enter. It worked again, and now this one, and voila. You will see system.io file not found exception. We again need to specify where the Raspberry.io is, right? So how do we do it here? Well, it's not actually the same thing as here with the /r, but we have actually multiple options. And first of all, we would have just to put the DLLs itself, the assemblies, right? The ones which we were referencing here. Yeah, right, like this, you know. We can put them in the same folder as the project, so I could just put all of these in here and it would work. Or, like, you know, the reason why I don't really prefer this often is because it's not that organized. I want to have my executable like alone, so I can actually see it. But that would work. The other one would be with the monopath. And the monopath, how it works is, let me show you this. Hang on. First, what I want to do is I want to have a folder which has all of them in it, right? So you could do something like in here, and assemblies folder. And now let's go back to our projects. And now we want to reference the DLLs. Now we want to use again Raspberry.io, all of these, you know. And don't, by the way, speed up the video because you think that you know which one you want to use, because we actually need to use more than we used for the compiling part. Hang on a second. So let's go just back to programs, assemblies, paste it in here. And we want to do this for all of them, you know, for all of the ones which we already used before and for more. So we also want to do this for net standard. The net framework, I mean. In here, copy back to programs, SPO, assemblies, paste it in here. I might have just rather done one folder right here, so and then you could just cut it and paste it in there, but whatever. Let's go back to our projects and Swan Light. And get it all back in here again. And now we need 2 more actually. And one of them would be, sorry, the swan. and the other one would be the raspberry.abstraction. I think the reason why we need to reference it now is because these packages depend on those as well, and for the compiling it's actually not that like important, because for compiling you just want to look if the syntax is correct. For the executing part, you need all of the references in order that the code knows what it actually needs to do, right? So we want to use the swan in here, right? Copy it. Programs, Raspberry assemblies, paste it like this, and also their abstractions. There we go, just like this. If I'm a little too fast, you can also just slow down the video. Wonderful. Now, once we have this, the way we'll actually want to let it know that we want to use this folder, because how would it know it, is there's one drawback to using this method, and this is that you always need to write export mono underscore path equals, and then the path you wanted to point at, right? So it would be in our case program slash raspberry assemblies, and yeah, that's basically it. But we always need to do this every time we open up a new session. Now, the way you could like not have all of the assemblies in the same folder as the program itself, and not needing to always reference this like export monopath every time you open up the terminal, would be to have it in the GAC, which is the global assembly cache, I think. But the problem with this one is it's always getting called up, which is like kind of the point. But you should only put there like assemblies which you actually need for all of the projects, and that's very rarely the case, because usually you have them like system, this one is one which you pretty much always want to use, but other than that, like, I mean, I don't think you always want to reference the Raspberry camera for all of your programs, right? So yeah, that's about it. And now if we execute it, it should already work actually. So let's just do this, programs, Raspberry and Raspberry.exe, and now, perfect. It took a picture, and we can look at it, and yeah, this would be the target path, right? And wonderful. Also, that's my wardrobe, just upside down. But yeah, I'm totally not flexing here. There was an actual coincidence. Cough, cough. No, yeah, but that's about it. No, it's actually the first time you can see that my camera's working. The other times it was just a preview, and which was on top of the recorder, so we didn't even see it. But here's actually working, so you can see it now. But this one's pretty simple, right? Straight up to the point. The more complex one is this test capture video. So now it should also be working. Let's. Oh yeah, of course we wanted to compile it again. Never forget this. And wonderful. Press any key to stop reading this video stream. Now I press one, and it has captured it. Now you didn't see a stream, but I didn't see one either. So it wasn't just because of the recording, but also because I didn't see it myself. And the reason for this is because default, like on the example, the capture display preview is set to false. You want to set it to true if you want to see something. Let's recompile it again, and let's do this. And now you should be seeing a preview for as long as as you press a key, right? So I'm seeing one right now. If you do the same thing, you should now also see one. And with enter, I'm stopping it, or any key. And also, you might ask yourself, well, capture timeout milliseconds is set to 0. Why do you see one? Well, 0 is basically infinite until the stream stops, right? It's not just nothing. But anything higher than 0, like 1 or 2, is just the amount of seconds. Alright, so that's basically it. But now, you might have realized that with test capture image, we can actually save the image. With test capture video, this does not happen, like we don't specify it anywhere. So how do we want to do this? Well, let's get back to this onData callback action. Now, this onData callback action is being called up whenever you get, whenever the Raspberry Pi camera is getting new data. So always, like during the recording, during runtime, it's going to call this action, and like execute this part of code. You can obviously like edit it, and yeah, that's it. Now the data here, this is the parameter, and the value which is being given here is the most recent data. Now this is very important. It's only the most recent one, so whichever the Raspberry Pi camera has captured right at the point before calling this action. And it's gonna be a byte array, right? So with this knowledge, what we can do is we can edit this code block right here, because like this is the data, we can reference it in here, right? We don't do it now, but we could, and this is what we're gonna do. We're gonna reference the data, and like what we want to do is we're gonna have here a var. It's called something like video, which is gonna be the entire video, right? So video stream, it's a better name, equals new list of byte. Now, very important that you write byte big and not small, even though this is a byte array, which is the primitive type byte, which is small. Reason, because you need to reference in here, you need to give us for this generic class actual class, not a primitive type. That doesn't work. And now the constructor call, right? Now, once this is done, what you can do is pretty simply, let's actually format this a little. Just so I can see a little more. There we go. Alright, wonderful. What we can do is for each, let's call it like var data part, because this is a single byte, since this is the byte array, right? In data. And now what we're gonna do with it? Well, quite simply, my Raspberry Pi is lagging right now a little. I hope that's not too much of a disturbance. Wait a second. Just like this. And now the way we can add it in here, like we now want to add this single byte always into this video stream. So how we can do this is video stream dot add data part. And now at the end, like video stream will then have the entire content of whatever was recorded. And once it's done, what we want to do is we just want to save it. So the way we will do this is well, actually, I just realized it doesn't really make sense to do this in here to save the file, because it's also going to do it if it went into exception. But if it went into exception, it most likely failed somewhere here. So you like it might not even have any value inside the video settings, and you don't want to save an empty file. So let's just do it in here instead. And what you want to do is you want to say, just as we did actually up here, file.write all bytes, file.write all bytes. Now we want to specify our target path, which I'm just going to hard code now. It's usually not preferable, but whatever. Let's actually say, I know, /home /pi /videos, I guess. That will make sense. And we want to give it a name like, yeah, stream.h264. And now we want to say which are the bytes, and this would be the video stream, right? There we go, video stream. Video stream, wonderful. And now, since this is a list with the type byte, but we actually like it actually space a byte array. The way you can do this with the dot to array, function. What it does is it basically converts the list with this type into the actual like primitive type, right? So it would make it a byte array. And yeah, it might hopefully already be working. So let's do this again, compile. Oh, wait a second. It may only apply within a local. Oh yeah, I didn't even notice this. Well, it's kind of. I'm usually working with, like I told you already probably 1,000 times with Visual Studio. It always tells you this stuff. I didn't even realize I was doing this outside of the method. I actually wanted to do it in here. Alright. Whatever. Oh, I can also not format. That's wonderful. Or at least I don't know how. So there we go. Save it. Use again. Yep. List could not be found. Oh yeah, it already tells you system.collections.generic because it knows of this. So copy it and let's use it in here like this. Wonderful. And type using in front of it. And now, actually, I want to do it just like this. I like when it's ordered a little. And the semicolon is also important. Now it should finally be working. Wonderful. Execute it and press any key to stop reading the stream. I'm gonna do something just so we can see that it's not like a still image. Enter. And now let's go into here, videos, and wonderful. Also, this recording part is actually something I did before, just to ignore it. Now, you can see stream.h264 here, right? And if we want to open it, we first actually need a media player. So the way we can do this is just open quickly the terminal and say something like, and we would have one here, but whatever. Sudo apt-get install and now VLC. This is just probably the most popular and in my opinion like the best overall media player. You can install whatever one of your choice that works for Linux. I'm just gonna install VLC, and after this is done we're gonna see us again. Alright, so VLC is installed now, so now we can open this, and it really didn't capture what I did, and that's actually like it was what I kind of expected to happen. And the reason for this is because you might have actually not even seen this extension .h264. What is it? Well, h264 is actually a codec, and what this means is usually you see something like MP4 or MOV or whatever, and those are actually the container ones, like the container extensions, which have a container and the content inside of them. Now, H264 is the codec, and this is like just the raw value, like the raw data, the raw content of whatever you've recorded. And it also kind of makes sense because we literally just got the bytes and we directly put it into our like video, right? And into our variable, and then we saved it as a file. So it's just gonna be raw content. But for media players to actually like be able to play it, like most of them need to have a container. And let me disappoint you, it's not as easy as to just like change the extension type to .mp4. This wouldn't work because remember, if you change an extension type, you're only changing well, how the file is being treated, but not the content of the file itself. So you actually need to convert it or encode it, how we would call it. And now you might think that we would do this in our code itself, right? Just like have some new assembly and then just call a method. And surprisingly, I actually I did my research on Google. Maybe I didn't do good enough, but it seemed that most people were saying it was actually quite hard, and the ones and they just told you to rather use the terminal, and the ones which didn't tell you to use the terminal but actually gave you the solution of how to do it in code, like there it really was actually quite hard. Like you could see it for yourself, and so I decided that it wasn't quite worth it to like have like I don't know like 200 more lines of code or whatever it was just for this. So I went with the option of going with the terminal, but I wasn't quite satisfied with this option because first of all, what we need, like there are two different tools for this. One would be FFmpeg and the other one would be MP4box. Now the difference between them is FFmpeg is probably more famous and maybe has more options, I don't really know. But for our use case of only needing to convert .h264 to .mp4, I kind of like MP4box a lot better because it managed to compile file was like 5 seconds in 0.5 seconds, while FFmpeg needed like, I don't know, 1 or 2 minutes. You could literally see the single frames being um, how they were loading. So I don't know what they did wrong there, but MP4 Box is a lot better in this. Maybe it's also just for my Pi, but still it always was the case that MP4 Box was just a lot better. Now the way you want to install it is would be sudo apt-get install gpeg, and we'll see ourselves after this is done. Alright, so I just installed it, and you should see now if we type in MP4 Box. Also, make sure that you type it like this and not just everything lowercase, or else it won't work. It's actually case sensitive. And press enter, and you will see like some of the stuff. If you get something like this, then it means you installed it and it's actually working. So congratulations. And now if we want to compile or encode .h264 into MP4, the way you can do this is MP4 box. We're going to use this tool -add. Then as the first argument, you want to give in the input file of the H264, which is already existing. So just go into videos / stream.h264, wonderful. And the second one would be the one in which you want to convert it. So videos stream. But instead of H264, you want to have an MP4, right? So press enter, and you can see it's insanely fast, like actually half a second. Yeah, and it encoded it. So now, if we double press this one, it might look better. Well, you can see it looks already a lot better, but in case it wouldn't work for you, because often it didn't. Like for me, it still had a lot of like cuts and jumps. It was just twice as fast because it skipped every second frame. And the reason for this would be that the resolution, if it's set too high and your Raspberry Pi can't handle it, then it's just going to skip frames. So one way to like play against it would be to just lower the resolution. And you can do this by like 1280 and 720p or whatever you want. You can justify that however you want. So now let us compile this again. Call again this and try to execute it. Alright, export monopath, as I told you, always needs to be set on the whenever you open a terminal up again. So do this if you open up a new terminal. Just set it to, what was it? Program / Raspberry Pi, Raspberry IO / assemblies, of course, yeah. And do it like this. Now if we do this again, it works again, wonderful. So let me record something again, and the hand movements might seem like smoother. So it did already actually seem pretty smooth, but for you it might actually like make the difference if before it had like it skipped frames. So now it shouldn't anymore, or at least less. You can also like adjust it and you reduce it even more. Now let's go into this and check it out. Oh, it might have actually not overridden it. Yeah, it didn't. I think, shit. I just accidentally closed it, but yeah, let's just close both of these. I think it doesn't overwrite the MP4 by default, if I'm correct. Let's just recompile it and call it like this. Oh, of course, yeah, the monopath again. Where is it? There we go. And now on using this, let's do my smooth hand movements again. It might look smoother. It used already to look pretty smooth, but if it didn't look smooth for you, like if it was actually doing frame skips, then you should see a lot bigger of a difference. You can even reduce it even more if you still have the feeling it reduces 2 frames, but I think it also just might be like the frames, that it doesn't really record a lot of frames at once, you know, like it has like 30 FPS if I remember correctly, or I'm actually not sure. Now We also need to make it into yes, MP4 again. Now if we check it out, yeah, I'm not sure if you can actually see that. I'm not sure if I can see myself that it actually is smoother, but the Raspberry Pi should have less of a problem of doing it now, right? Alright, so now it's I told you before that I wasn't quite satisfied with this option, and the main reason for this is because I always, whenever I do this code, you kind of realized it already probably, I need to manually convert it into an MP4. So how can we work around this? Well, I actually found a pretty good solution, at least I think so. And my idea was, well, if we need to use the console, then why don't we just do it inside the code? Now, I just need to find out how to do it. I'm going to go back to your programs. Raspberry O, perfect. And yeah, I actually found a pretty good solution. So let me just quickly, what was it? How to, I think I typed this in. Or perhaps not. Wait, hang on a second. I think we can also just use the shell helper bash. Shell helper was the class, bash was the method. Oh, there we go. This is it. I might put this link in the description if you need it. Wonderful. Alright, now we also need to import system.diagnostics. And yeah, let me first of all just copy this in here. Hang on. Just like this. And since it's a new class, no, this is the class itself. My scroll wheel doesn't actually work all that well. Hang on, there we go. And now, what we can actually do is, like, let me show you let me show you it first. So, after this is being done, right? After the files have been written, what we can do is we want to execute what we did here before, right? This MP4 box part. So let me just copy this. And again, it's kind of hard coded, but whatever. Let me paste this in here. There we go. And now dot bash. And it should be executing this in the terminal. Now, how does this actually work? Now, if we were to not make this method static, then what we would need to do is usually just make an object of the shell helper class and then make this object.bash. But since we're not actually like referencing any of our properties, I mean the shell helper class doesn't have any, and we're like not changing any properties or like setting them or returning any of them, it doesn't really make that much sense to make an object. Now, if we just use static, then what usually would happen, we would need to make shell helper.bash and then the type in the string as the parameter of like what we want to execute. But this is probably what I like the most because we're actually extending the string by this bash method. And the way it works is just like a normal static method, but this is the important keyword. This, you're saying the next type is the one which you want to extend this method by. And what's basically going to happen is whatever string you use, if you use no bash, which you can use as the method, it's just going to execute this code block, right? And this is just yeah, the way you want to call the terminal. And now if we compile this again, just like this. Oh yeah, right. I told myself, I always get reminded of what the mistakes are before. I even see the error message, but I just sometimes forget it because I'm speaking and this kind of distracts me. Yeah, now I'm blaming you audience, bad audience. Alright, so let's do this again. It works. And let's do this. And now, if we're doing this, hang on, I just think I noticed something. I'm clicking enter. Wait, I think I didn't delete. Yeah, right. Okay, let's delete it again so we can actually see it works. Now, hi there, I'm showing 5 fingers, so you can see that it's an actual difference to the last recording, and it's not the same one, that I didn't do like any trick, you know. So now let's actually, yeah, you can see it made already, it made a .mp4 file, so you can kind of probably expect already for it to work. Let's just open it. Here are my 5 fingers that I'm always opening as a kind of evidence to show you that it actually works. And other than this, yeah, it's actually, I think it's pretty good working now. Now I made actually an issue on the official like Uno Square repository, which wasn't actually an issue. I think I already talked about it. Let's go to it's closed. And what was it? It was there we go, COD Pro 2005. I know it's a very good name. Now my issue was that, like as I told you before, I had this frame skips and all this kind of stuff, and but I then I first of all didn't notice what the problem was, but later on I realized it was because of the capture width and capture height, because sometimes my Raspberry Pi had the power to actually do it with 920 times 1080p, but like now, but most of the time it actually didn't, so I'm quite surprised it worked now. And yeah, but I just posted this because I thought something was wrong with my code, and other than actually that the resolution being too high for the Pi to handle, there wasn't anything wrong with it. So now what we can do is, because I refactored this code a little better, slightly, we can just use this one instead. Paste it in here, save, and just quickly, there's a little less hard coding in here. Like I'm specifying a file right here, and giving them, and also I'm actually first capturing the video and afterwards I'm doing the H.264 to MP4, because it's two different things, right? And what I'm also saying here, you can see I gave here a true, and the reason for this is because I said well, first of all, if the file exists, then I'm deleting the MP4 file, which is good because now the overriding won't be a problem. We don't always will need to delete it, right? And now if the remove H.264, which is the parameter which I passed through in, then it should remove the H.264 file, because like sometimes you might not want to do this, but most of the time you probably want to, because the H.264 file is really just what you want in order to encode it to the MP4, but once you have the MP4, we really don't need the H.264 anymore. So I'm leaving the option to not delete it, but it's recommended to do it, right? And yeah, so just to show you that it actually works, I'm gonna record now. Wait, this again. Not forget to set the mono path. There we go. Now let's execute it. And I'm actually gonna show my face for the first time. How's it going? You know that I haven't deleted the videos and like any of the videos, right? So the overriding also works, and the H.264 should be deleted because it's set to true. Enter. Yeah, it's extremely fast. Now let's go to File Manager, Videos, and oh wait, I call it recording in here, and I call it stream here. So whatever. So recording is the actual file, but you can see it's deleted the H.264. If I'm gonna open it now, my face is here. Well, I kind of missed the camera, but whatever. And just to show that the overriding works, because that wasn't kind of the proof, let me do this actually again. And now let's show my elbow, I guess. I know that's not that good of an idea, but whatever. And you saw something was happening here. And now my elbow, yeah, there we go. So overriding also works. So that's about it. I hope you enjoyed this and could learn anything out of it. Sorry if I did some mistakes or something. I'm not the professional with doing guides. It's my very first one. But anyways, if you liked it, please give me the grade 6, Laurin, and I think Andreas, right? Alright, so that's about it. yeah, bye.